All right.
So what I just sent you transcripts from your computer knowledge to
All right, are we ready? Okay. Today we are covering area between curves. So in the past, we have done area under a curve. Okay, so this is a situation where we did area under a curve. Okay, if we're doing area under a curve, it means we're doing the integral of something, correct? So this one would be the integral from 0 to 4 of x squared. And then we'd put dx after that, right? That's what usually goes there. So what's the integral of x squared? So we're doing x to the third divided by 3 from 4 to 0, which is 4 to the third divided by 3 minus 0 to the third divided by 3, which gets us 64 thirds. 4 to the third is 64. Okay, so we did it that way. So that was algebraically. And we've also talked about doing this using your calculator, so if we did it using our calculator, there's two ways you can do it. I'm going to do it without using the graphing part. So I would go to math. Fn int is number 9 here. And then it allows you to plug the integral in. So we're going from 0 to 4 of x squared dx, which gets us 21.3 repeating, which is 64 divided by 3. Okay, so is there any questions about that integral? Okay. Today we're doing area between two curves. You're kind of close. So what you do, so this is an example where we have two curves. So we have this curve that's on top and the curve that's on bottom. You guys see that? And so what you're going to do is you're going to integrate both, okay? So you're going to integrate the top one and subtract the integral of the bottom one. Yep, and so here's what's happening is, so you find this area here, so I'm highlighting that in green. Okay, so do you guys see how that's the area under that curve? And then you're subtracting off this section here, so that all you're left with is that in-between part. Okay? So that's what you're trying to do, is you're taking the area under this curve and subtracting the area under that curve. Okay? Now, this is an example of a no calculator problem. And the reason I know it's a no calculator problem is because they gave you the graph. Okay? So you know which one's on top and which one's on bottom. So how this works is you would integrate your top. So I would integrate secant squared of x. And I'm going from 0 to pi over 4. Do you guys see that? 0 to pi over 4. Minus, I'm going to go from 0 to pi over 4 again, but this time I'm doing sine of x. Any questions about how I set that up? Okay? We haven't integrated yet. Okay? So if you integrate secant squared, you get tan of x, correct? So I'm doing tan of x from pi over 4 to 0 minus, if you integrate sine of x, that's negative cosine of x, correct? And again, you're going from pi over 4 to 0. Now, these are ones that you need to know for your test. Okay, so I'm going to do the tan one first. If we look at the graph of tan, the graph of tan looks like this. Where at pi over 4, you hit the number 1. And at negative pi over 4, you hit negative 1. Okay? So if I'm looking at tan at pi over 4, minus tan of 0, what is tan at pi over 4? So this is 1 minus 0 from this first part. Yep. Now I'm going to do cosine of x. Cosine of x, okay, pi over 4 is a 45, 45, 90, right? Do you guys remember that? 45, 45, 90. Pi over 4 is 45, pi over 3 is 60, pi over 6 is 30. So pi over 4 is 45. The cosine then would be 1 over square root of 2, which is good. So when you do tan of pi, or no, we're on cosine, aren't we? Cosine of pi over 4, you get square root of 2 over 2 minus cosine at 0, which this one I use the graph for. What's cosine at 0? 1. So cosine is adjacent over hypotenuse, so that gets you that. And then you times top and bottom by square root of 2, so you get square root of 2 over 2 from that. Now, we have a double negative here, so what does that change into? Plus, what happened? We have 1 minus 0, so that's 1 plus square root of 2 over 2 minus 1. So what's our answer? Square root of 2 over 2. Now, a couple of things I want to let you know about. You can either leave this separate, or you could combine them and do secant squared of x minus sine of x. I like keeping them separate. It's a personal preference, just because it lets me do piece by piece. Okay, but some people like putting them together. And so if you did get to use a calculator for this, how you could plug this in is you could plug in math, so we're integrating 9 from 0 to pi divided by 4. What is secant? Close. 1 over cosine of x, and then you have to square that. Oops, I put my square too soon. Squared, and then it's minus sine of x, and then dx. This one you have to make sure that you're careful on your parentheses because of this garbage happening, okay? So just be careful with your parentheses. And you should get 0.707, which if you plug in square root of 2 over 2, you get the same number, okay? Me personally, because this is so much garbage to plug in, I felt like it was actually easier to do the algebraic version. You know what I mean? Like sometimes the calculator is faster, but it's hard to plug stuff in. And secant squared is one example of that. All right, are you guys ready for the next one? So for the next one, it says find the area of the region enclosed by y equals 2 minus x squared and y equals negative x. Okay? So for this one, did they give us a graph? No. So typically when they don't give you a graph, they want you to graph it on your graphing calculator. So if I graph that on my graphing calculator, I have 2 minus x squared, and then I have negative x, correct? Is that the other one? And then I would graph. Okay, so there's my graph. Now remember, it's top minus bottom. So in this picture, the blue one is on top the entire time, correct? Okay? Like here's my red line, it's above it. Like location-wise, here blue is on top, here red is on top. Okay? So blue is on top. They want this region that encloses both of them. Okay? So they want, it'll always be some sort of weird shape here. Okay? What does it look like we're going between? -1 and 2. Now, typically you want to make sure that those are the numbers because sometimes they like to make it look like it is, and they like to kind of mess it up for you. So to find where it is exact, you choose 5 intersect, and you'd get as close to the intersection as possible and find that your intersection is -1. Okay? And then you would do the same thing to find that the other one is 2. Do we need to do the other one, or are you guys okay with me telling you it's 2? We're good? Use the x coordinates. So -1 to 2 is what we're using. So then that's telling us that we are going to integrate from -1 to 2, 2 minus x squared, minus from -1 to 2, a negative x. So let's integrate both. For this first one, we get 2x minus x to the third over 3 from 2 to -1 minus, this would be a negative x squared over 2 from 2 to -1. So now we have to plug in some numbers. So if we plug in 2, we're going to get 4 minus 2 to the third over 3 minus, if we plug in -1, we get -2. See, -1 to the third is -1 minus, so it'd be plus 1/3. Is everyone okay with that? Okay. And then I'm going to separate this. Actually, no, I'll just put minus. No, let's separate it. All right, I'm going to separate it. So then we're going to do -2 squared over 2 minus a -1 squared over 2. So notice how when I plugged in the -1, in the second one I used parentheses around the -1. So I'm going to solve these separately, and then once I solve them, then I'm going to put that minus in. Okay? I just feel like it's a lot going on to do this minus before we're ready. Does that make sense? Okay, so here we get 4 minus 8/3. And then minus, let's see, that negative would distribute, so it'd actually be plus 2 and minus 1/3. Is everyone okay with that? So then you get 6 minus 9/3. That gets you 3 for this first part. Is everyone okay with that? Any questions on that? So now we have to do this one. So that's going to get us a -4 over 2. Plus 1/2. So that's -2 plus 1/2, which is -1.5, correct? Or -1 and 1/2. And now I'm going to apply this negative. So I get 3 minus -1.5. So what's my final answer? 4.5. This is an example of one where I think just plugging it into the calculator might be the easier way. So if we plug that into our calculator, we would get, let's see, math, int, oh, that's not what I wanted. Here we go, math, int from -1 to 2, we said, correct? Is everyone okay with that? And then it's 2 minus x squared, and then it's a minus -x, right? So I can change that to plus x dx. You get 4.5. Okay, so that's one where it's actually easier to plug it in your calculator. All right, what's our next one? Find the area of the region enclosed by the graphs of y equals 2 cosine of x and y equals x squared minus 1. So we'd have to graph this first, right, and find those intersection spots. So So 2 cosine of x. And then what's the bottom one? X squared minus 1. Okay, so here's my graph. If you didn't get it, it's probably because you're not in radian mode. Did you get looked like 2 straight lines? Yeah, it's because you want to be in radian. There you go. All right, so then you would do second trace intersect and get as close to 1 as possible. Well, to one of the intersections. So you're going to try to get as close to one of your intersections as possible. I have negative 1.26424. Yep. And then it's the same but positive. On these, it happens often that they're different just a little bit, right? So make sure you go out as far as you can to make it as accurate as possible in the end. Nope, we're going to use all of them. So we're going to do integral of negative 1.265, is it 454 is what I found?
Negative 1.26542.
Yep. What did you get? Yep. So go out as far as you can because it'll make your final answers accurate. And then on the top end, it's the same number but positive, correct?
That last 4 is, that last 5 is 2.
Yes. This is a 2. 4, 2, 4. Okay. So that's what you're integrating, and you're doing 2 cosine of x minus the integral between those two of x squared. Now, naturally, we don't know how to plug either of these into cosine of x, correct? So yes, I would say this is one that they'll definitely let you use your calculator. So I would get out of my graphing mode. I'd hit math. -1 like this. And I would integrate from negative 1.26544 to positive 1.26544. 2 cosine, oops. Two cosine of x minus, and then this x squared minus 1 has to go in parentheses. Or you could, if you wanted, you could definitely, I need one more parenthesis.
Why don't we do the integral of x squared and stuff like that?
If you want, you can do them separate. or you can do them together. It doesn't matter, but if you do them together, you have to put parentheses here, whereas if you did it separate, you could just integrate, close integrals, subtract, integrate, close integrals. So that might be easier for you guys to plug in, then you don't have to worry about as many parentheses. So my way, I got 4.995. Okay. All right. Now, there's one more thing we need to talk about. I don't know that we're going to do this one, but sometimes weird things happen in these area under the curve. So for example, do you guys see how this is actually two, like top, bottom, it changes here? Like, if this had kept going, it should have been all the way down here, but it cut it off here. And so when something like that happens, you would do the integral from 0 to 2 of square root of x. Okay, because it's just area under the curve to the x-axis like that first one we did. There's no, do you guys see how there's no equation under it? Yes. And then from 2 to 4, it's the integral of square root of x minus from 2 to 4, the x minus 2 part. Okay? So sometimes something like that happens, where, so you would find this, you'd find this, and then the two areas put together are your total area. Does that make sense? Yeah, you have to break it into two parts. Okay? The other thing that is common to happen is they'll give you an x to the third function, kind of like this, and they'll have an x squared function come through, and you have to find the 2. So what do you guys notice happens right here? On this one, this would be on top, okay? And on this part, the other one goes on top. Okay? So when that happens, you'd have to integrate, you'd have to do it like this, but you would integrate from here to here with this one on top and this one on bottom. And then you'd integrate again from here to here with now the one that was on bottom goes first and this one goes second. Okay? And there is a couple like this in your homework so that you can get some practice with it. Okay? So